Hello and welcome back to another IB Math Speedrun with me, Vince. So we're going to be going through the final exercise in Chapter 6, which is about related rates of change involving trigonometric expressions. So let's dive right in. So in the previous chapter? I think it's the previous chapter. We covered how to solve equations with related rates of change. So in other words, parametric equations. And so this time we will simply just be involving some trigonometric equations along with them. So let's jump right in to some questions. So I'll do the even ones and let's start with the first one. So we have a tourist is filming from a spot that is 30 meters from the tree, following birds that are moving at a speed of 90 kilometers per hour. The birds are moving perpendicularly to the line joining the tree and the spot. Find how fast the tourist must rotate the camera when the bird is directly in front of the camera, and B, 1 second after the bird is directly up in front of the camera. So this looks alright. So we have a spot that is 30 meters from a tree, and the birds are moving perpendicularly. So I'm going to assume it looks something like this, where we have 30 meters and the birds are moving at 90 kilometers an hour. So if we sketch out a diagram, we know this is 30 and this is some distance d. So we know the rate of change of this distance with respect to the time. That is dt over dd. Horrible variable name, I'll do capital D, over dt. Is the speed of the birds. It's 90 kilometers an hour. And we know how fast, well actually we know the relation between the distance from the birds and this angle over here. So we have, let's label this angle theta, and we have d theta over dd is equal to let's scale back a bit. We know that theta is equal to arctan times d over 30. So d theta over dd should be equal to 30 over 900 plus d squared. So now we can combine these two equations. So we need to find d theta over d time. So this is equal to d theta over dt is equal to 90 times this. Just multiply these two. So we get, this is what is this? 900 times 3, 2,700 over 900 plus d squared. So, yeah, plus d squared still. Since, I guess we should find some way to express d in terms of theta, which we do actually. We know that d is equal to 30 tan theta. So do over dt, actually we want to express this in terms of time. So d over dt, that's not useful. When the bird is directly in front of the camera. Okay, well, I guess we can do it this way. So when the bird is directly, actually no, we do have a relationship. What am I doing? We have d is equal to 90 times time, more or less. So we can substitute 90t over here. So this would be equal to 8,100 t squared. And so now we can solve. So when the bird is directly in front of the camera, this is equal to 2,700 over 900. Sorry, 2,700 over 900, which is equal to 3 degrees, I believe. So this should be 3 degrees per second. Oh, but wait, oh, this is in kilometers, degrees per hour technically. Sorry, I mean radians per hour. So we need to actually divide this. So we get 3, and then we need to divide this by 60 because there are 60 minutes in an hour. And then divide by 60 again. So we get something like 0.00. So it needs to rotate at a speed of 0.000. So actually we need to divide this by 3,600. So we get that this is 0.000833 rotations or radians per second. And so next, if it is flying 1 second after, so this is 2,700 divided by 900 plus 8,100. So that's equal to 0.3. So 0.3 over 36,000 is equal to, well, I'm getting 0.0000833. Yeah, this question is a bit weird. Okay, so yeah, on to the next one. So next, we have a balloon has a spherical shape. There is a hole in the balloon, and the air is leaking at 3 centimeters cubed per minute. Find the rate at which the radius is decreasing when it is 10 centimeters. And finally, find the rate at which the surface area is decreasing when the radius is 4.5 centimeters. So, I mean, this one doesn't even involve any trigonometry. This is dv over dt is equal to 3 centimeters a minute. Okay, fine, 3. And we know that dv over dr is equal to 4 pi r squared. So if we get dr over dt is equal to 4/3 pi r squared, when the radius is 10 centimeters, this is equal to 400 over 3 pi, which is equal to 400 over 3 times pi is equal to around 418.9 centimeters per minute. Oh, sorry, no, I messed this up. That's way too much. It should be 3, because we have dr over dv, so this is actually 3 over 4 pi r squared. So we have 3 over 400 pi. So 3 over 400 over pi is equal to 0.002 cm per minute. Next, for surface area, decreasing when the radius is 4.5 centimeters. So we need to know the area over the volume, dA over dV, and this is equal to, let's link this up. So we have dV over dr is equal to 4 pi r squared. The surface area is equal to 4 pi r squared, so this would be 8 pi. So dA over dV is equal to 8 pi over 4 pi r squared, which is times dr over dV, it is 2 over r squared. Yeah, 2 over r squared, and then we're finally multiplying it by 3, so this is 6 over r squared. So this should be equal to 6 over 4.5 squared. So something like 0.296 cm squared per minute. 8 pi r. Oh, 8 pi r. So this should only be 6 over r. So yeah, sorry. This should only be 6 over r. So 6 over 4.5 is what? 4/3. It's 1.333 centimeters squared per minute. So yeah, that was that one. And we have the final question now. So the final question is, a train is moving along a straight track at 75 kilometers per hour heading east. A camera is positioned 2 kilometers west of the train track and is focused on the train? What? This question is just not correct, since if the train is moving this way and the camera is directly behind it, since it's west of the train track, which is straight, moving east, so I'm just going to assume it's perpendicular. I'm going to assume they mean that it's perpendicular and this distance is 2 and it's moving at 75 kilometers per hour. Because that seems reasonable. So find the rate of change of the distance between the camera and the train when the train is 4 kilometers from the camera, and find the rate the camera is rotating at this point. Okay, so can I move that? I can move that? Yep, okay. So when the camera is 4 kilometers, when the train is 4 kilometers from the camera, okay, well, when it's 4 kilometers, we know that, let's label this distance d again. So we know that d squared plus 2 squared is equal to 4. And of course dd over dt is equal to 75. Okay, no. So I have an idea. So we have d squared, the distance squared, and then let's call this like a diagonal c. I don't know why. So d squared plus 2 squared is equal to c squared. So we have c is equal to the square root of d squared plus 2 squared plus 4. In other words, so we have dd over dt is 75, and dc over dd is equal to 2d times d squared plus 4 to the power of negative 1/2. So actually this is just d times d squared plus 4 to the negative 1/2. Rate of change of the distance, well, with respect to time, multiply these two, we have 75 d times d squared plus 4 to the negative 1/2. And we know that this is when the train is 4 kilometers from the camera, so this is 16. 16 is equal to d squared plus 4. 256 is equal to d squared plus 4. So we have 256. Oh, sorry, no. We have 16. So we have d squared is equal to 12, so d is equal to 2 square root 3. So we need to find the point where d is equal to 2 root 3. What's happening at this point? So we have 75 times 2, 150 root 3, times d squared plus 4 to the 1/2. So it's just divided by 16. So this is equal to 150 divided by 16 times the square root of 3. So it's equal to 16.2 kilometers per hour. I think that is the rate of change. Or is it not? Oh, sorry, 4. Wait, so it should only be over 4. So this should be 64.9, since I forgot the square root. So this is like 64.9 kilometers an hour. That's the rate of change. And we need to find the rate the camera is rotating. So again, we can label an angle here. We can say that it's equal to the tangent of d over 2, arctan. So tan of the angle is equal to d over 2. So we have d is equal to 2 tan times the angle. So dd over d theta is equal to 2 secant squared angle. And we need to find the rate of change of the angle. So we know the rate of change of time. So we need to go 1. Actually, why are we working with the angle here? Let's just use the implicit method instead. Okay. So we have O is equal to tan d over 2. So we have do over dd is equal to 2 over 4 plus d squared. And so we need to multiply this by 75 to get d over dt. So do over dt is equal to 150 over 4 plus d squared. When d is equal to 4, this bottom part will equal 20. So we have 150 over 20. This is equal to 15 over 2, 7.5. 7.5 in radians, though. So this is 7.5 degrees radians per hour. So first, let's convert this to degrees. So we have times 360 divided by 2 divided by pi. 75 times 360 divided by 2 divided by pi. And then we need to divide by 3600. So, I'm getting a different answer to the book. I wonder why is that. 2 over 4 plus d squared. Distance is... Oh, and the train is 4 kilometers from the camera. Right, so this is actually... This distance here is only 2 times root 3. So we actually have 150 over 4 plus 2 times root 3 squared. So 4 plus 12, 16. So it's 150 over 16. Which does shake things up. So times 360 divided by pi divided by 2. And then we have to divide by 3600. Because 4 plus d squared is 12. So it should be 7.5 not 7.5 radians anymore. So 150 divided by 16 should be like 9.375 radians. So we have times 360 divided by 2 divided by pi. 537 divided by 3600. I'm getting something very different. If it's 4 kilometers, actually, let's just use sine. Maybe let's try sine. Maybe that will work. So we have theta is equal to sine. Actually, cosine d over 2. Cosine c over 2. C over 2. So this is equal to 1 do over dc. Yeah, because that was probably my mistake. Because we were substituting it into d. So we should get 1 over the square root of 4 minus x squared. Minus c squared, I believe. So we get from here, this should be 75 over 4 minus c squared. Is this minus c squared or plus c squared? Unless we go, it might be 75 over root 20 if we take the opposite distance, since, yeah, I guess it would be 75 over root 20. So we have 16.7 radians, and then we divide by 2 divided by pi times 360 divided by 3600. Yeah. So that was it. It should be, so this should be actually 75 over 4 minus c squared. We input c is equal to, I say 4 plus c squared. C is equal to 4, so we get 75 over square root 20. So this is equal to around 12. And so what we simply have to do is we need to multiply this by, divide by 2 pi. Is it 12? Wait, 75 over root 20 is equal to, 16.7. 16.8. So if we divide by 2 pi times 360 divided by 3600. So we end up with actually, yeah, we end up with something like 0.27 degrees per second. The book is saying something different. The book is saying that, but multiplied by 2. Multiplied by 10, and so I think it's a rounding error on the book's part because they forgot to divide by this extra 0. So yeah, that was all for the speedrun. I hope you enjoyed it, and I hope to see you in the next one.